It's a mysterious game of hide and seek when we marvel at the pictures taken during manned space missions. A crucial detail always seems to be missing, namely the stars. But why is that so? After all, it's easy to spot the thousands and thousands of twinkling stars in the sky on Earth. In fact, the missing stars in the Apollo photos are even cited as supposed evidence that the images were not actually taken on the moon at all, but in a secret film studio. But does it have to be so conspiratorial, or is there a much simpler explanation for the mysterious absence of the radiant heavenly bodies? And above all, what does an astronaut really see when he enters the endless expanse of space? We all know Yuri Gagarin and Neil Armstrong, but have you ever heard of Bruce McCandless? Just like his more famous astronaut colleagues, the American also made space history. On February 7, 1984, McCandless became the first person to complete a spacewalk without a safety line. However, the pioneer walker didn't have to manage without a little help. When McCandless left the space shuttle, he was carrying a 140 kilograms rocket engine on his back that allowed him to maneuver in space. In the end, he spent 4 hours and 55 minutes in space in this way, and he moved up to 100 meters away from his spaceship. At first glance, you might think that such a foray into the infinite void would be incredibly calm, almost meditative. But surprisingly, McCandless did not describe his unsecured space excursion as contemplative in retrospect. On the contrary, on the one hand, there was the space junk in Earth's orbit, which can quickly develop more penetrating power than a pistol bullet and would have turned the mission into a full-blown catastrophe if it had hit the shuttle. And then there was astronaut Bob Stewart, who also plunged into the deep black of space shortly after McCandless. Not to mention the ground crew and the other crew members in the space shuttle, who were chatting wildly over the radio the whole time. And so it came about that McCandless later summarized his groundbreaking walk with the single word loud. But if you like, this description is in stark contrast to the photos that subsequently went around the world because they leave us absolutely speechless. They show a lonely astronaut apparently drifting all alone through the vast expanse of the universe and away from the Earth, which presents itself in the pictures as a bright blue circle. Nothing but the pitch-black infinity greets us in the background. But why is that actually the case? Shouldn't the scene be overflowing with countless stars? Well, of course it should. After all, our Milky Way alone is home to an estimated 100 to 200 billion of these twinkling formations. But if the stars are there, why can't we see them in the photos? How the stars become invisible. Another mission, same picture. As is well known, the photos of the Apollo 11 mission also show a confusing stellar game of hide and seek. But shouldn't the stars have been particularly easy to see due to the moon's lack of atmosphere? Well, you might think so. And in places where the radiant heavenly bodies are in short supply, it is considered more likely in certain circles that it was too complicated for the set builders in their secret film studios to recreate the thousands and thousands of stars in the correct constellations. The official explanation, on the other hand, sounds somewhat different, and it justifies the absence of stars with the short exposure time of the photos. Basically, the surface of the moon reflected the sunlight so strongly that not even the astronauts themselves could see the stars. To make the faint objects in the background visible, the images would have had to be exposed for a long time. But this would have resulted in the astronauts and the lunar surface being overexposed and thus unrecognizable. A short exposure time hides the stars in the sky, but in return shows the actual subject of desire, namely the Apollo astronauts at work on the moon. And of course, NASA didn't send people to the moon to capture particularly impressive images of the starry sky. After all, this could also be done from Earth. Consequently, the cameras were deliberately set to short exposure times. And anyone can easily verify for themselves that this is accompanied by the optical disappearance of the stars. Given that the Earth's atmosphere is largely transparent to light, anyone who takes a photo of the night sky with a short exposure time will notice that no stars can be seen on it. Fundamentally, we must not forget that the stars in the photos taken by the space missions are not isolated. In other words, the blackness of space is always distorted by the bright surroundings of the astronauts. The spaceship, the space station, the crew, and, of course, solar radiation always produce a significant amount of light that outshines the background stars, which are comparatively weak. This effect is already apparent to us when we look at a street light that brightens the night sky near it and makes the stars invisible. But even if the environment were darker as a result of space missions, the stellar field of view of astronauts would still be limited. In fact, this initially sounds like a contradiction. After all, there is no atmosphere in space to block the starlight. However, this is also associated with the fact that there is no light scattering in the vastness of space. Without light scattering, stars appear as tiny dots that can only be seen if they shine very brightly. How this theoretical framework is put into practice becomes clear when we listen to the report by Canadian astronaut Chris Hadfield. Having gone into space 3 times between 1995 and 2013, Hadfield helped to assemble the robotic arm on the ISS during 2 extravehicular activities. He described the scene before his eyes as follows. You hold on with one hand and watch the world spin by. It rushes quietly past you with its colors. And if you take your eyes off it and look down at the rest of it, you see an unfathomable blackness with a texture that makes you feel like you could stick your hand in. What Neil Armstrong reported about his view of space sounds very similar. The first man on the moon said, "The sky is pitch black when you look at it from the moon, just like from the cislunar space, the space between the Earth and the moon." Armstrong also noted that from the lunar surface, he could only see the Earth and the sun, but no stars. Though perhaps he was lucky to be able to see anything at all after the Apollo 11 mission. About astronauts with poor eyesight and technical hurdles. At this point, it should be noted that although the view of the Earth from space is an unforgettable experience, it's also associated with high risks. In fact, about 2/3 of astronauts on long-term missions report that their vision is rapidly deteriorating. In the case of John Phillips, his vision even decreased from 100% to 20% after 6 months in orbit. But why is that actually the case? Well, in this regard, NASA experts have found that the so-called visual impairment and intracranial pressure, VIP, syndrome is not due to the bright reflectivity of any surfaces, but to the effects of weightlessness. This is because it causes the amount of cerebral fluid to increase significantly, which then presses on the highly sensitive structures in the eye. The result is reduced blood flow and damage to the optic nerve. Unfortunately, studies have shown that this deformation inside the eye and the associated visual impairment do not always go away after the astronauts return to Earth. This makes the camera-based view of space seem much healthier. Well, as long as it wasn't so limited, of course. But is it at all? After all, we all know those space photos that take our breath away with their mind-boggling details. And they do indeed show stars. However, the details of the foundations for a successful image in space are laid in advance. Unlike our pupils, most space cameras are not equipped with apertures that allow them to adapt to changing light conditions. Instead, scientists predict the lighting conditions that a camera will encounter during its mission and construct the instrument's apertures accordingly, ensuring that they are appropriately sized for the range of expected targets. And then, as already mentioned, there is the exposure time. True to the motto, longer exposure times capture more light. The images that show us the night sky as a starry spectacle are long-term exposures that often last many minutes. Space cameras are also capable of covering a very wide range of exposure settings. For example, the technical eye of NASA's New Horizons probe is capable of taking pictures with exposure times between 1 millisecond and 30 seconds. When the spacecraft passed Jupiter, which is much closer to the Sun and therefore significantly brighter than Pluto, the shortest exposure time was selected. For the distant structures of the Kuiper Belt, the longest exposure time was used. Incidentally, this also answers another frequently asked question about space images. How can cameras take pictures so far from the Sun, where the light is so weak? The answer to this question lies in a combination of highly sensitive cameras and, if necessary, long exposures. But what happens when the cameras are not sensitive enough for their mission? This becomes clear when we take a closer look at a few old Voyager 2 snapshots. Originally designed for the conditions on Jupiter and Saturn, the camera struggled when trying to capture the structures in the relative darkness of Neptune. And so it happens that the best Voyager 2 images of the Neptune moon Proteus only resemble a celestial body when we close both eyes. If you enjoyed this video, please subscribe to our channel, Digital Discoveries. Don't forget to like and share the video with your friends and family. Thank you so much for watching and supporting us. See you soon in our next video.